So, am I sharing the slideshow over 2 pages in 1 page? I'm not sure which one are you. You can see.
Yep, we are seeing first page of the slide. It's a survey
Oh,
of
okay.
explainable systems.
Okay.
The
Thank
title
you.
is slide.
Thank you. My name is Hyoil Han, and this work is done with my student. So it's about a survey of explainable recommender systems. So I'll present motivation, background, and we classify the explainable recommender system based on their approaches to generate explanations. And then we will discuss about the ERS, explainable recommender systems, and I will conclude. So the motivation of this work, now the rapid advancement of AI has driven the adoption of machine learning techniques across various domains, and user-centric applications become increasingly sophisticated. So providing just the recommendations is not enough for recommendation systems, because the user does not know why a certain item was recommended to them. So now by providing explanations along with the recommendations, we want to improve the user trust, so that user knows why certain items were recommended to them. Explainable recommendation systems bridge the gap between the recommendation without the explanation and recommendation with the explanation. So by providing explanations along with the recommendations, we can increase transparency, user understanding, and trust through the understandable explanations. So we want to strive to balance high recommendation accuracy as well as the clarity of their explanation. So sometimes when we improve the accuracy of a recommendation, we cannot provide a good explanation. So the balancing the accuracy and the easy explanation, that is very important, and it's not easy to do that. So the applications of explainable recommender systems are expanding beyond the e-commerce domain. So nowadays, the explainable recommender systems are used in medical domain too. So as a background, the definition of a good explanation, so it's very subjective and also depend on largely on the specific goals of the recommender systems. And also explanations are crucial in enhancing user experience, and especially when we build the trust, so the user knows why certain item was recommended to them. Without understanding why the recommendation is provided, the user would not be trusted the recommended items. So we want to persuade the users to purchase certain items, so that to do that, we want to build our trust between the recommendation system and users. So designing explanations. So explanation in the recommendation system explains the generated recommendation and also increase the user satisfaction and trust and loyalty. So there are 7 criteria for the explanation: transparency, scrutability, trust, effectiveness, persuasiveness, efficiency, and satisfaction. So we want to improve all these criteria to provide a better explanation. So user needs to understand how the system works and on what factors the recommendations are made to the user, so to improve the trust between users and recommended items. when we present explanation to the users, so we want to, because the presentation will have impact on the user persuasion and satisfaction. So the explanation presentation is important. So, and also the recommended items, it can be item, the recommendation can be item or conversational system or interactive, interactive system or visual graph. So we can provide an explanation interface. So it's a technique that helps to understand why an item was recommended to the user. And also the interface contains 3 elements: explanation, presentation, and interaction. So from now, in the paper, we classified the explainable recommended systems based on their technique in several approaches. So I want to introduce those things. Because this paper is a survey paper, we are introducing the existing approaches and then what kind of techniques are used in each approach. So attention-based approach is attention mechanism has become widely adopted in neural network. So it enhances interpretability in recommended systems and make recommendations more transparent. Here, recommendations is recommended items or recommended books. So you can consider recommendations as recommended items. And also this attention-based approach leverages an attention mechanism to assign personalized weights to features so that we can identify, select the most important ones to provide as explanations. So in attention-based approach, there is a system proposed by a researcher, is attention multi-personal collaborative filtering, and it learns user personas and uses them as a basis for providing explanations. And in explainable recommender systems, so before explainable recommender systems are introduced, there was just recommendation systems. So those recommender systems is just recommending items to the user, so they're without explanations. So so those things is provide. So there are 2 different. Later, I'm going to introduce, but just to help understanding. Nowadays, how people generate explanations is first using a model, using recommendation model, they create first recommendation list, and then add the explanations to the recommendation list. So in this framework, it first generate recommendation list and then provide the explanations to those recommendation lists. So it dynamically adjusted the weights of each persona so that it can create user representation and generate interpretable recommendation based on their importance. And also using local and global features, the explanations are generated. So focuses on capturing visual preferences and then combine these visual preferences with the reviews and regional features through the attention mechanism, and then combines global and local attention to better capture the user item properties and semantic meanings so that it can generate interpretable representation for of users and items. And then the next approach is a GRU-based approach. So GRU is gated recurrent unit. This is a type of recurrent neural network. So it utilizes a gating mechanism and requires less memory compared to LSTM networks. So over the years, the use of GRUs in recommender systems has gained significant traction. So applying GRUs, so it to generate word sequences that serve as textual explanations for recommendations, and also GRUs are applied to map user and item latent factors and learn the hidden states and produce word sequences that explain the recommendations. So to calculate word sequence probabilities and generate natural language explanations, also GRU used. And then the next approach is rule-based approach. So rule-based approaches, it leverages logical associations to generate explanations. So rule features are used to generate explanations. So items are assigned weights based on associated rules. The rule with the highest score is selected as the explanation for the recommendation. Recommender systems always have items and item information and user information. So how we find the associations between users and items, that's one of the bottom line or base work in recommender systems. One framework that uses rule-based approach is the Hyper framework. It leverages probabilistic soft logic PSL to recommend items based on predefined rules. And so it learns the predefined rules, then generate explanations tailored to various styles influenced by personal, social, and item-specific factors. And next approach is a template-based approach. So template-based approach, it uses predefined structure to generate explanations. So to generate so we are providing in template-based approach, we provide multiple templates, and then using those templates, we can generate explanations. So recommended items, which template should be applied to the recommended items. So that is the main part. So because it has a template to explain the recommended items, so how many different kinds of template you provide that can give impact on the final explanations. So template-based approach combines feature opinion pairs or employs case-based reasoning because we provide in advance template, so we can consider each template as one case-based reasoning. So it provides clear and structured insights into recommendation. And the next approach is a path-based approach. So this is the path-based approach plays a crucial role in enhancing the interpretability of explainable recommender systems, and the relationship between the users and items contains rich semantic information. So those by extracting through the path, we find the relationship between user and items, and the relationship leverages this extracted information and incorporates it into their models to improve explanation quality. The next approach is a factorization-based approach. So it utilizes latent representations to model user preferences and explanations simultaneously, and it is used to integrate features and produce interpretable predictions. The next approach is a line-based approach. This is local interpretable model agnostic explanations. Is model agnostic means we have a model to generate a recommendation, then we add the explanation to the generated item. So this is it's a very famous method. The most of recommended systems use model agnostic method. So this is used to generate explanations by analyzing the importance of features in predictive models. So its applications span many domains. So from text-based recommendation systems to visual recognition tasks. So it can enhance interpretability across different modalities. Next approach is aspect-based approach. So this approach focuses on user and item attributes to provide explanations for recommendations. And this approach generates explanations aligned with the user priorities, thereby enhancing decision-making. So it constructs preference and quality metrics and uses it to generate explanations. The last one is hybrid approaches, and this one combines multiple techniques to enhance interpretability. So by integrating neural networks with the probabilistic models or knowledge graphs to enable dynamic and context-aware explanations. So when I explained, I told model agnostic systems. So explainable recommender system, there are two different types. So it's how we categorize these two types is based on how explanations are generated. So model intrinsic systems, this one is we generate explanations and recommendations together at the same time inside the model recommendation model, and it leverages inherently interpretable frameworks. So framework itself to generate recommendation that includes explanation process. The other one is model agnostic systems. It generates recommendations after we generate recommendations. So explanations and recommendations, they are generated separately. So the model agnostic systems is easy to generate. It's easy to generate explanations because the recommendation model are separated from explanation generation. So most current recommended systems belong to the model agnostic category. So what I presented today is mainly it's about so we conducted an in-depth analysis and classification of existing models and approach. So those approaches are used in explainable recommender systems. And what I presented today is mainly used in model agnostic systems. So the explanation generation process, if it's included in the recommendation model, that is more difficult actually. So that is not deeply investigated in this field. So our future work, we plan to focus on further advancing model intrinsic explainable recommendation systems. So this one is a model and explanations are generated together in one recommendation model. So this area is not widely investigated yet. So this is our plan. Thank you very much. If you have any questions, I will be happy to discuss it.